So as we know in yesterday's class, we discussed the pseudo force. So pseudo force is nothing but Newton's second law as we discussed. So generally we'll say Newton's second law, force is equals to mass into acceleration. But what is the pseudo force formula we have done? Pseudo force is equals to minus of ma. So means this pseudo force is acting always opposite to the direction of what, guys? Opposite to the direction of what? Yes, please. Direction of
Acceleration.
direction of observer's acceleration. Understand, Laksha? Observer's
Yes, sir.
acceleration. Okay. So please keep it in mind that whenever we are using the pseudo force, we are using that non-inertial reference. Means in the sense of observer's acceleration is not equals to 0. So wherever observer's acceleration is not equals to 0, but still if you want to apply the NLM, what do you mean by NLM, everyone?
Newton's laws of motion.
Newton's laws of motion. Then we will introduce a concept called as pseudo force. Now, observe very carefully. So what is the concept we have studied in yesterday's class? If observer acceleration is upward direction, then the pseudo force is acting what direction? Everybody? Downward direction. If observer's acceleration is like this direction, then the pseudo force acting in what direction, everybody? Backward direction. So that is what is called as pseudo force. Am I right or wrong? Everybody clear? That is
Yes,
what we
sir.
have done in yesterday's class. Right or wrong? All of you? Yes or no?
Yes, sir.
Yeah. So now in our today's class, we are going to see a concept called the same pseudo force case in the case of inclined surfaces. I'll draw perfect figures, perfect concept. Anything, anywhere you have small doubt also, you have to kindly ask me. So now for that purpose, I am taking an inclined surface. You can see. So we all know that this is called as inclined surface. Like this inclined surface, we already solved one time. Do you remember, everyone? Second chapter, third chapter, we solved already. Yes, please.
Yes, sir.
Yeah. So there is an inclined surface mass. So let me rotate it and keep it. So this is a mass which is actually kept on the inclined surface. Okay. Now is it clear, everybody? So now let me take the mass of this inclined, object which is present on the inclined surface is actually small m. What is the mass of this one, everybody? Mass of this one is small m, and the mass of this inclined surface is capital M. What is the mass of the inclined surface, everybody? Yes, please. Capital M.
Capital.
And the angle here is actually the theta. So now if is the theta means we all knows that in a slope, if here is the theta means, then everywhere it is what is the angle? Is it remembered, everybody?
Theta.
Yes, please. Constant
Yes,
angle will be theta. Everyone involved, anything doubt you have to ask me. Now observe very carefully. So now imagine the inclined surface is moving with the acceleration a in this direction. So what is our target is find acceleration of m. Acceleration of m, capital M. Question, observe all of you. Find acceleration of m such that m, small m is at, understanding, rest with respect to capital M. Do you understand, Pradosh, what I'm saying? So when you are trying to drag, for example, the inclined surface is pushed forward direction. So the inclined surface is dragging, moving forward direction with acceleration a. But here what is happening? The small m should not slide over it. Do you understand, all of you? Yes, please. What is the question? The small m should not slide over these inclined surfaces. So without disturbing the inclined this small m, the mass of the object, we have to provide the acceleration a to the inclined surface so that it will move forward direction. So what is the acceleration of capital M such that m is at rest with respect to m? Do you all understand what is the question? Everybody clear? Yes or no? Please respond. Now,
Yes, sir.
so imagine that observer is here. So observer is here. So observer is also having an acceleration of how much? If inclined surface having acceleration A means observer is also having acceleration of how much?
Yeah.
Yes, please, A only. So means in the sense of it is an inertial frame of reference or non-inertial frame of reference?
Non-inertial.
It is the non-inertial frame of reference. So in this case, immediately we have to apply. What is the concept we have to apply, everybody?
Pseudo force.
Pseudo force. Okay. Now for the time lapse, I will draw the same diagram, all the things, but you have to draw separate diagram for this. Do you understand, everyone? Samya, Aswita, clear? Till here, anything doubt you can ask. Mr. Narayan, Rohit. Yes, please. Everybody clear? Understand? So now, as we all knows that, if here is the theta, so let me draw now, all of you observe very carefully. We have drawn already for inclined surfaces. So there is a something which is acting downward direction. So what is that acting downward direction? All of you for the surface. Weight of the object. That is what we used to call as. How much it is?
mg.
Weight of the object is how much? Mg. So now, if it is weight of the object mg, as we know, acceleration is forward direction. So at that point, there is a force, pseudo force, which is acting opposite direction. What is the pseudo force, everyone? Yes, please. Pseudo force is equals to. What is the pseudo force? Pseudo force is equals to how much, Amma? MA. That is what.
-7.
Yeah, pseudo force is equals to MA. Now observe all of you. So here, there is always, we all studied the normal reactions and all. So always normal reaction perpendicular to the surface. This is what the direction of normal. Am I right or wrong? All of you, will you agree with me or not? Yes,
Sir.
please.
Yes, sir.
So if the weight of the object is acting like this direction, we studied two things, X component and Y component. So can you tell me what is X axis and Y axis? What is happening? Suppose now here is the theta will come. So now here what will happen in this component? Theta is happening here. So here is the theta and here also theta. Then X axis and Y axis. Can you tell me what is the X component will come? Fastly. X direction. We studied already inclined surfaces.
Sir, mg sin theta.
MG, fastly everybody. MG.
Sin theta.
So if here is the mg sin theta, then perpendicularly to this, that is what 90 degrees angle. So because here will be the theta means here 90 minus theta. So here how much it will come? Mg
Cos theta.
mg cos theta. So this is we all people knows. Am I right or wrong? Everybody clear?
Yes, sir.
Yes. So now if you have taken here, pseudo force is also acting. For pseudo force also we have to make it now. If the pseudo force is acting in this direction, so we all knows that at that point. So again, if I make the force which is acting perpendicular, check it everybody. So this is what perpendicular direction. If here is the theta means, so here something will come. What will happen? MA cos theta will come.
Cos theta.
In this line, what will happen? MA, this one.
Sin theta.
MA sin theta. So here two things will come. MA cos theta and MA sin theta. Brothers, do you understand this point?
Yes, sir.
Clear? So this is for normal case. If observer is inertial frame of reference, so we all people knows that mg, weight of the object, is acting downward direction. So that x-axis mg sin theta and y-axis mg cos theta. We all people know. But now as it is a non-inertial frame of reference, so we have to consider for one more new force. What is that force we used to call, everybody? That is only we used to call as
Pseudo force.
pseudo force.
Pseudo
Pseudo force is also acting with a angle theta. So that at this, so now here also X component and Y component. So X component which is acting opposite direction, that is what? MA cos theta, and Y component which is acting MA. Yes, please. MA sin theta. So MA sin theta. So as soon as if you represent an X axis and Y axis, this MG will disappear. Always we have been made that. Do you remember, everyone? All of you? Yes, please.
Yes.
Yes. So now draw the FBD diagram for free body diagram for small m. So small m, if you observe very carefully, so this is what the small m I have taken. So there is a force which is, let me take now, all of you observe very carefully. There is a force which is acting like this direction, and there is a force which is acting like this direction. Same way, normal. There is a force which is acting normal, and there is a force which is acting downward direction. So downward direction, two forces are acting. What is that? One is pseudo force and another one is weight. Mg, this is what? Mg cos theta and as well as pseudo force. What is that? Mg,
MA sin
Ma sin theta. And same way here, x-axis, what is happening? This is x-axis and this is y-axis. So here what is happening? Mg,
sin theta.
Mg sin theta. And we are know that this is the force which is acting, pseudo force, Ma. So here Ma means this is Ma sin theta and opposite one here what will come? Ma
Cos theta.
cos theta. Because as it is theta is here, so Ma cos theta will come. So these are the forces which will exerting on small m. So now you can write the equations. So what will happen? Equations opposite, because this body should not move. Should not move means this all the forces must be equal. Am I right or wrong, everybody? Yes, please.
Yes, sir.
Balanced forces. If it is a
Balance.
balanced forces only, then only the M should not be slide over the inclined surface. Only the inclined surface will start moving forward direction. Do you all agree with me? Yes, please.
Yes, sir.
Respond. So that's all. Now, so what is that? N is equals to normal is equals to what is that? Mg, respond, Mg cos theta plus
MA sin theta.
Ma sin theta. So let me take this is equation number 1. And next second equation what? Ma cos theta is equals to, fastly,
MG sin theta.
Ma cos theta is equals to Mg sin theta. Till here any doubt anybody can ask. Laksha understand, Laksha? Pradosh?
Yes, sir.
Mm will get cancelled. So mm will get cancelled. Now if you observe, I will write A is equals to G into sin theta by cos theta. So sin theta by cos theta is equals to something. What is that?
Tan theta.
Tan theta.
Tan theta.
Acceleration. Acceleration A is equals to how much, everybody?
G tan.
G tan theta. Now, so what is that in place of normal reaction? So we want to know what is a normal reaction, so that we have to make it. So normal reaction, how much should not slide over? So normal reaction is equals to, what is the formula? Check it, everyone, all of you. Mg cos theta plus M. A means what? Everybody check it. A means what?
G tan theta.
M
Tan theta.
tan theta
G tan theta.
into sin theta. So that is what the normal reaction. So this is how we have to make pseudo force concept in inclined surfaces. So do you all understand, everybody? Clear? Anybody having any doubt, you can tell. Understand, everybody? Yes, please. So as the weight of the body is acting downward direction, so we all knows that. So here the angle will be how much it is? What is the angle here? 90 degrees. Yes or no? So as we know, here will be the theta means in the sense of, then this will become 90 minus theta. So two components will come. One is x component, another one is y component. Y component mg sin theta, mg cos theta, and x component what will happen, everybody? mg sin theta. Same way for pseudo force. So for pseudo force again there is a two things. One is again as pseudo force is acting with the surface with the theta angle. So this side it is theta is here. So that theta ma cos theta, and as well as this one only it is what is actually ma sin theta. Okay. So then with that acceleration, if you slide over the inclined surface, then small m should not slide over the capital M. That is what inclined surface. It will be remain stationary. If you are making the acceleration, A is equals to G tan theta, and as well as normal reaction, the normal reaction mg cos theta plus mg tan theta sin theta, then this small m won't slide over the inclined surface, but inclined surface will move forward direction with the acceleration A. So this is the concept of pseudo force in inclined surfaces. Do you all understand, everybody? Can you able to imagine or not, everyone? So nothing is that. Generally, if it is the inertial frame means we all people knows, we have done already. So inertial frame means if there is a mass, so we all people know, so weight of the object is acting downward direction. So there is a x-axis. What will happen? Mg, all of you, mg sin theta, and perpendicularly to that, what will happen? Mg cos theta, and normal reaction n. So we have done or not, everyone, this concept? Yes, please. So now additional to that, this is for observer Inertial or non-inertial frame? Observer is in what, guys? Everybody.
No, sir.
Inertial.
Inertial.
Now, instead of inertial observer, we are making non-inertial observer. That is what non-inertial frame. So that if the acceleration of the inclined surface is A, means observer acceleration is also A. So then we are introducing the new concept called as pseudo force. That is what pseudo force is, always opposite to the direction of acceleration. So acceleration is forward, means pseudo force will be in what direction, everyone? Backward direction. So for this one, as it is making the theta angle, then here what will happen? MA, all of you, MA cos theta will come. So for this one, as we know, this is 90 minus theta. Understanding this is the theta means, then this is only will come. What will happen? All of you, MA. Yes, please. MA sin theta. Okay. So that is only the new thing we are adding. Because of pseudo force, there is another two components, MJ cos theta and MA sin theta. That's all. Understand the rest now? Clear? So
Yes,
I
sir.
got take Rohit. So this pseudo force concept we don't know. If it is an inertial frame, already we know that y component is mg cos theta and x component is what? Mg sin theta. So we all people knows that. We already studied long back. Am I right or wrong? Yes. That is. So please solve it. Have you all understand or not? Ishali, Aswita?
Yes, sir.
So very important concept is this. Now based upon this, we are going to solve one of the toughest and important sum related to from the H.C. Verma book. So if it is completed, then I will proceed with that. Do you all understand? Everybody completed or not? Yes or no? Let me know. Can I start now? Yeah. So now you can draw one inclined surface. See, for the time purpose, I am drawing only one inclined surface, but you have to redraw again and again. So there is an inclined surface. All of you observe very carefully. And there is a mass M is placed. Everyone, you proceed and you make it. Okay. So I will try to draw the question. You also draw from H.C. Verma book. You can find it also. I have sent you the soft copies also. So you all can find that book. Okay. So let me take. This is one of the important question. If you understand this question, that is enough for us. So there is a M, mass M, and all of you remember, and the mass of the inclined surface is M dash, not M. What is the mass of the inclined surface, everybody? M dash. And this inclined surface is pulled by with the help of some pulley. With the help of some pulley. Understand for those? So there is a pulley which is tied to that. So now what is our target? The M, small m should not slide over the what? Small m should not slide over the inclined surface.
M dash.
M dash. But the inclined surface should move forward direction. So that is what? So what is the mass of this body? So that the small m should not slide over the M dash and this body should move forward. So this inclined surface should move forward direction. So that is what is our target. So now, what is our question in this question? We have to find what is the capital M. So that is only. So this is one of the very important question from the H.C. Verma. So the question is, what should be mass of hanging block? What is the hanging block, everybody? Capital M. Am I right or wrong? Yes, please.
Yes.
Yeah, for which small m does not slide over M dash. Clear, everybody? Mr. Narayan, can you understand the question? So we have to find what is the capital M mass so that the small m should not slide over the where? Everybody, slide over the M dash. That is what is our question. So as we all know that this is the same string, so the tension will be remains what? All of you.
Same.
Yes, please. Same. You please redraw the diagram again. Okay. So now as we know, this M is acting downward direction. So the downward something will acting. What is that, everybody?
Weight.
Weight of the object. Very good. So from this itself, so same string, same tension. From this I can write first equation. Can you tell me, Mr. Yoga? Mr. Anybody can tell me? Can I if it consider that this is whole as a single system. So what is that? Acceleration is downward, so it will become positive and it will become negative. So what is the equation will come? Capital
mg minus t
minus
equal to
T is
ma.
equals to capital MA. That is what?
Me.
F net is equals to MA. Is it okay, Laksha? Shall you understand? So this is the equation number
Yes.
1. Okay. Now, as we know, this is the inertial frame of reference and non-inertial frame of reference. Observer is here. So that inertial frame of non-inertial frame. Non-inertial frame. So
Non-inertial.
observer is, if the inclined surface is moving with acceleration A, here means, then here something will act. What is that? Fastly.
ma.
MA. That is only called as what, everyone?
Pseudo force.
Pseudo force. Clear? So if it is pseudo force means we all know. So this all the this see this M should not slide over. Means in the sense of this M and M dash both are as a single system. Am I right or wrong? Like one block over the another block. Yes, Mr. Pradosh? M one block another over the another block. So this whole we can consider as a single system. Am I right or wrong? Everybody? Yes, please. Yes. So that is what you should remember. So that we all know that pseudo force is acting two direct. One is this direction. What is that? X-axis. Mg respond. Mg sine theta and opposite one which is acting something. What is that? Ma.
Cos.
Ma cos theta. Right or wrong? All of you understood or not?
Yes, sir.
Yes. So now observe very carefully. As this body does not have, like you can see this body is moving in this direction, so there is no kind of thing, so only tension, one force is acting, that is the force equals to T. So T is equals to, as I consider this whole system as a single, so that what is the second equation will come? T is equals to, everybody? Yes, please. There is a force which is acting T, so T is equals to what? Net force is T is equals to F net equals to MA. Respond. Whole system I am considering. F net equals to MA means. So F net is T, tension. So T is equals to net mass M dash plus M into A. Am I right or wrong? Do you all
Yes, sir.
agree with me?
Yes, sir.
Yes or no? All of you?
Yes, sir.
Yes. So if you want, you can draw that one. So there is a mass. So 1 mg Ma cos theta and which is acting downward mg sin theta. So this both are considered as a single system. So that single system means only acceleration A. So that single force is acting. That is a force we used to call as tension. So what is the equation will come? Tension T is equals to, everybody? Yes, please. T is equals to M dash plus M. So first equation, capital Mg minus capital T is equals to capital Ma. Second equation, T is equals to capital M plus small m into A. So add the both the equations, something will come. What will happen? Everybody, add the equations. Both the TT will get cancel. So we'll get how much, guys? Capital Mg is equals to this one. I'll make it Ma plus this multiply with that M dash A plus small ma. Am I right or wrong? Will you all agree with me?
Yes.
Yes. Now, MA will bring this side, small ma or capital Ma. Both capital M is there. So capital M will come this side. What will happen? All of you. Capital Mg minus capital Ma, which is equals to, here A is common, so I will take it as A common. So which will turns into capital M dash plus small m. Right? All of you? Will you agree?
Yes,
Yes. So we all knows that. We know that. So mg minus, if you notice it. So this one, A means what? We already studied. A means acceleration. Ma correct this is. So acceleration means what? We already derived it inclined surface. Acceleration is equals to, please. We already derived before case. G
tan theta.
G tan theta. So in place of acceleration, I can write what here, guys?
G tan theta.
Tan theta, which is equals to here again mass capital M plus small m. Again A means what I can write?
G tan theta.
G tan theta. So that is what. Now if you notice it in this one, so something you can take it common, all of you. What is you can take common? Look into the board and tell me screen. Mg common, so that 1 minus tan theta is equals to here also capital M plus small m into G tan theta. So both the sides something is common. I can get cancelled. What is that? G get cancelled. So capital M is equals to 1 minus tan theta, which is equals to m dash, capital M dash plus small m into tan theta. Am I right or wrong? Will you all agree with me?
Yes, sir.
Yes. All of you? Yes or no?
Yes.
Yes.
Yes, sir.
So it will turns into
Yes,
capital M. We want to find what is capital M. That is what is our target. So capital M is equals to capital M dash plus small m into tan theta divided by what will happen? Everybody, 1 minus
1 minus tan theta.
1 minus tan theta. Okay. Now both numerator and denominator divide with the tan theta. Divide with what? Everybody? Both
Tan theta.
numerator and denominator divide with the tan theta and tan theta. So what will happen? Numerator, everything. This tan theta will come down. Like all you can feel like both divide with the tan theta and tan theta. So up to what is remaining, guys? Capital M dash plus small m. Am I right or wrong?
Small.
Everyone, Manya, understand Aswita? Capital M plus capital M dash plus small m divided by here 1 by tan theta because minus tan theta
Minus 1.
tan theta by tan theta. Am I right or wrong? I'm dividing with
Yes, sir.
both numerator and denominator so that it will turns into capital M dash plus small m divided by 1 by tan theta means what? 1 by tan. Anybody?
Cot.
Yeah, 1
Cot.
by tan theta is equals to cot theta. So cot theta minus 1.
Minus 1.
That is what is the capital M. So if the M is equals to M dash plus M divided by cot theta minus 1, then the small m will never slide over the capital M dash and it will goes both together, they will goes with the acceleration A. Do you all understand how much tough it is? All of you? So if you are having a proper imagination and everything a skill, it is easy. Do you all are able to understand or not, Mr. Rohit, Mr. Murali? So that is how we have to find it. So what is the capital M value? Capital M is equals to everybody. Capital M dash plus small m divided by cot theta minus 1. So this is how we have to find what is the M, capital M required to pull the inclined surfaces without oversliding the small m on inclined surface or small m over the capital M dash.